We are rolling. I videotape my lectures so that if they're ever confused, they can go back and rewatch them. Or if you're missing, if you're shadowing somewhere else, you can always watch them that night. So we're looking at chapter 11.2, right? You've already mastered chapter 11.1. That was new material for you, 11.1. 11.2 is not new material. You learned all of this last year, everything in this section. So it's all really kind of going to be review. And what I am going to do is, for the lecture, is I'm going to use the examples that are in the book, okay? Just so that I'm just encouraging you guys, I'm just trying to focus on the book a little bit right now to give you that. So example 1, it says, use the product property of radicals. Now then we think, well, what's the product property? That's in the blue box. It says the product property of radicals is something like this, where if you have the square root of A times the square root of B, that is equal to the square root of A times B. You can actually put them underneath the same radical. Or you could do it the reverse way. You could say, well, the square root of C times D is equal to the square root of C times the square root of D. Okay? So this is really useful if you're simplifying. And I'll just preface this real quickly. A lot of what I'm going to teach you is kind of absurd. And the reason why is because it was invented before we had calculators, right? And so before calculators, you wanted simple numbers. You wanted, when you're dealing with square roots and radicals, you wanted something simple. Because how many people know what is the square root of 1?
1.
Right, what's the square root of 2?
1.4. 1.6.
It's 1 point. It goes on forever, right? It's 1.12. I don't know. So what happens is the square root of 3. It goes on forever. It's an irrational number, right?
What's the square root of 4?
It goes on, and then the square root of 4 is even, right? But square root of 5 goes on forever. Square root of 7 goes on forever. Square root of 11 goes on forever. Oh my gosh, to memorize all these things take forever. So if you can simplify them back before computers, then it was really useful. But truthfully, what I'm going to teach you right now, or what I've already taught you really, it's not that useful, because with a calculator, it's so much quicker to put the square root of 32 and it'll give you an answer, right? You don't put the square root of 16 times 2, square root of 2, which is 4 times the square root of 2, and then and then do that in your calculator. It's so much quicker to just do square root of 32.
Wait, then why are we learning all this?
But you're learning it because it will be on all the tests. It will be on your SATs and your SATs. Probably not for some of them. But you'll have. But for some of your standardized tests that you take, you will not have a calculator, and they will, or even if you do, they will ask you to simplify it. Right? And so you have to know how. So using these concepts, if it said, this is the first one, square root of 32. This is example 1. Example 1. Okay? Square root of 32. You're looking for the largest perfect square that's in 32.
16.
And our perfect squares are 4. Well, one doesn't really help you, because 1 times a number is that number, right? I mean, so you're going to start with 4, 9, 16, 25, 36, 49, 64. You're looking for those. Which of those goes into 32?
16.
4 and 16, both, right? But you want to choose the bigger one. It's quicker. So watch. That's the same as this, the square root of 16 times 2. Do you agree with me?
Yes.
Yes? All right. That's the same as square root of 16 times the square root of 2. You agree with me?
Yes.
What's the square root of 16?
4.
So that's the same as 4 times the square root of 2. Right?
Yes.
And that's what they're asking you to do.
Oh.
Now, you tell me, is it easier to take a calculator and put square root 32, or is it easier to do 4 times square root 2? It's going to be square root of 32 is going to be easier if you're using your calculator, right? Back then, though, nobody knew what the square. I mean, they knew there were charts in my textbooks. At the end of every math textbook, there were pages of charts that would give me the square root of 1, the square root of 2, the square root of 3, the square root of 4, the square root of 5, the square root of 6, the square root of 7, the square root of 8, the square root of 9, and all that stuff, right? But the whole idea was to simplify, so you only had to deal with a few of them. That way you could memorize the square root of 2. You could memorize the square root of 3. You could memorize the square root of 5. You know, and just the simple ones. And hopefully, most of them you can simplify just from memory. See what I'm saying? So anyways, that's historically why you get taught this stuff, yeah.
What happens if like the largest perfect square root that actually fits into it is 1? Like
then it's a prime number, right? So that means you're just going to have, like 11, right? Square root of 11, I can't simplify that anymore.
It is simplified.
It is simplified, right? I could say, well, that's the square root of 11 times the square root of 1, but square root of 1 is 1. 1 times the square root of 11 is the square root of 11. You didn't get anywhere, right? You could do it all day, and you'd have a great time.
And
you have the square root of 11.
Right?
1 times
Okay.
square root of 11.
So for something like that, okay, we'll try one more. Square root of 48. 48. All right. What goes into 48? Let's see. 9? 16. 16 times 3, right? Oh, well, that's easy again. Square root of 16 times 3 is the square root of 16 times the square root of 3, which is 4 times the square root of 3. Right? How about square root of 12? That's the square root of 4 times 3. Square root of 4 times the square root of 4, I'm doing this fast, times the square root of 3 is equal to 2 times the square root of 3. So, and there are other reasons for learning this, because eventually we're going to be adding things with square roots. And to add them, you have to have the same number under the square root sign.
And you're going to have an irrational thing, because you couldn't break all the numbers and be correct, because there's infinite of them.
Yeah. So, all right. So that's example 1. Now, that was 1A technically in the book. That was example 1A. And then there's an example 1B, but I got to erase this so I have room for B.
ruh-roh. Do you want more time, Gary?
I'm racing, but you know, I'll just do my best. All right, so this is 1B, example 1B. 1B. And they said the square root of 9x cubed. The square root of 9x cubed. Now, with these, we not only have a number, but we have a variable, right? So maybe before I do this, let me just, well, it's okay, we'll do this. So that's the same as the square root of 9 times the square root of x cubed. Am I right?
Yep.
Yes? All right, square root of 9 is what?
3.
Okay, so now I can simplify that. I'll go down like this so to make it easier. 3 times the square root of x cubed. Well, the easiest way to do this, to teach it, is to say this is the same as 3 times the square root of x times x times x. Do you agree with me?
Oh, or x times x squared. Yeah, we did this.
Isn't that right?
Yes.
All right, now watch. This is a square root sign, so there's a hidden 2 right there. If there is nothing, you just assume it's a 2 there. If it was going to be like cube root or fourth root, you'd have to have a 3 there or a 4. But like a cube root would mean you have three of the same numbers times each other, right? If it was cube root, my answer would be x, right? Because I could take all 3 of these and they would come out as 1x, right? But this says I need 2 x's to come out. So look, I'm going to circle 2 of my x's. They can come outside as just 1x. And this has to stay, that's left over, it stays under there.
3x
so
times the square root.
I'm going to have 3x times the square root of x. Okay? So that's one way to think of it. That's one way to think of it. Another way to think of it is like this. 3 times x cubed is the same as 3 times x squared times the square root of x. I mean, right? Don't you agree with me? That's the same thing. I'm using that product property of radicals, right? So,
And then you get the same answer.
so yeah, what's the square root of x squared?
X.
X. 3x times the square root of x.
Another way to do it is like you can like take away, like if the cube root, you take away 3 x's, and if the square root, you take away 2 x's. So you like take away 2 of the exponents.
And you don't like
take away from
Yeah.
dwarf existence.
Yes. Okay. Say it again. What?
So if there's a 2 there, but there's a 2, you take 2 of the x's from the inside and you put them on the outside square root side.
Yeah, you only put one of the 2 though. You know what I'm saying? Because the square, like if you had,
But
like,
you took 2 of them and put them out.
where? Oh, yes, I take 2 of them, but they come out as 1.
Right.
Because it's the square root of 2 of them, which means 1. Right? See what I'm saying? Yeah, right. You're right. Yes.
What if it was x to the 5th?
Okay, so let's say it was x to the 5th. So, so we'll do square root of, we'll do 12x to the 5th, okay? We'll try this. So, square root of 12, first of all, is the square root of 4 times the square root of 3, right? Times the square root of x. I'm going to do x to the 4th times the square root of x. If that exponent is an odd number, I make it an even number because that will have a perfect square root. What's the square root of x to the 4th?
X squared.
X squared. So then I'm going to have, what's the square root of 4? 2. So I have 2 times the square root of 3. Oh wait, and this comes out as an x squared, right? This came out as a 2. So let me rewrite this, sorry. So I have 2x squared, and then square root of 3 times the square root of x, but with my product property I could combine these, right? Right? So I could have 2x squared square root of 3x, and I'm done.
2x squared is 2.
Just follow me?
Yep.
Who did I lose? Who said no? Karen? Alright, so follow. Let's look at it. Square root of 12. It's the square root of 4 times the square root of 3, right? Alright, square root of 4 is 2. So now I've got 2 times the square root of 3, right? Square root of x to the 4th. It's basically the square root of something with an exponent is that something with half of the exponent. So think about it. X squared times x squared is x to the 2 plus 2, which is x to the 4, right? So that comes out as an x squared. We still have this extra x underneath the square root sign that we have to keep. So we have 2x squared, square root of 3 times the square root of x. But remember, the product property said you could do the square root of a times the square root of b is equal to the square root of a times b. So I'm just combining them under the same one. So there's my answer. Okay? So I'm going to have to stop there. Tomorrow we'll really focus on the rest of the section.
Problems?
So problems for tonight. I would like you to also read, I want you to read through the examples, okay? And then the problems that I want you to do, let's do page 723. 3 through 10. And
13 through 15.
how about 15 and 16?
Can you write about
What did I just say?
3 through 10.
Page 723, numbers 3 through 10 and 15 and 16.
Number 3 through 10, and then what?
15 and 16.
15 and 16?
Yeah. And page 723.
Page 723.
That's good enough. That's fine.
Page 723.
And then tomorrow it'll be a little bit longer. But read the chapter. Also read the chapter. Read all the examples, okay? Hopefully you'll remember what we learned last year.